Hello everyone, I am back again. Today we are going to be talking about limiting reactants. Essentially what happens is in a chemical reaction we have multiple reactants generally. Let's say we have a synthesis of water from hydrogen and oxygen. Let me balance this. Okay, let's say we have this reaction. Usually what will happen is one reactant will run out first. So in this case, let's say hydrogen runs out first. If hydrogen runs out first, since I no longer have a reactant, since it's all used up, my reaction stops. So once I use up all of my reactant, my reaction stops. Right? I can't have the reaction keep going if I've already run out of something. So the limiting reactant is the reactant that will run out first and therefore stop the reaction. Or it limits the reaction. It's the limiting reactant. Okay? To find the limiting reactant, we essentially have to calculate how much product will form given each reactant. So we'll be doing two stoichiometric equations. In this case, we'll be doing one for hydrogen and one for oxygen. And we'll figure out which one runs out first. In order to do that, we need a couple of givens. So let me write this in blue, make it stand out a little bit more. Let's say if I have 10 grams of H2 and 50 grams of O2. So I have 10 grams of H2 and 50 grams of O2. Say react to form 50 grams of H2O. What is the limiting reactant? And percent yield. Okay, so in this case, let me stand over here so I'm not in front of it. If I have 10 grams of H2, so I have 10 grams of H2 and 50 grams of O2, and they react together to combine 50 grams of water, it's asking what's my limiting reactant and what's the percent yield. The percent yield is essentially how well your reaction did, how well your laboratory situation did. The percent yield is your actual, my actual result is 50 grams, over theoretically what I should get. And theoretically what I should get will be the answer to the limiting reactant. So they kind of all nest together. So I'm going to be doing two stoichiometric equations. My first one is for H2. You know what, I'm going to actually write that, because I have the color. I'll write it in green. It's kind of fun. Happy little green. Okay, so I start with what I'm given. I'm given 10 grams of H2. I put it over 1. I know the molar mass of H2 is 2.02 grams in 1 mole. From my balanced equation, I know that for every 2 hydrogen moles, for every 2 moles of H2, 2 moles of H2O form. Okay, this is from my balanced equation. For every 2 moles of hydrogen, I get 2 moles of water. And then last but not least, I know that 1 mole of H2O weighs 18.02 grams. So now I can just double check my math. Let me grab my black marker here. I'm crossing out. Make sure I have, all my units will cancel out. I've got grams of H2O, grams of H2O. Or, I'm sorry, grams of H2, grams of H2. Moles of H2, moles of H2. Moles of H2O, moles of H2O. And I'm left with grams. Let me add a little bit more detail here. I'm left with grams of H2O. So I do that math out. And try it mentally. 2, 5, 12. Oh, I think it's 89.2 grams of H2O. Ooh. Okay, so given 10 grams of hydrogen, I should get 89.2 grams of H2O. So let me do the other one with oxygen. Step off screen there. Let me grab a red marker, very Christmassy. It's not really Christmas time, but okay. So for O2, For O2, I have 50 grams. Right here, 50 grams of O2. So, 50 grams of O2. I know I'm a little bit on the low side. Let me kick this chair out of the way. Hopefully it doesn't block you. Okay. I know my molar mass is 32 grams in 1 mole of O2. I know that for 1 mole of O2, I need 2 moles of H2O. And then lastly, I know that 1 mole of H2O is 18.02 grams of H2O. It's a little bit long. There we go. All right, let me once again do my little crossing out thing. Make sure I've got the appropriate equation here. I've got grams of O2, grams of O2. Moles of O2, moles of O2. Moles of H2O, moles of H2O. And I'm left with grams of H2O as my unit for my answer. All right, a little bit more mental math here. Give me a second. 5, 2 over 32. All right, it's 1 over 18. I'm going to say that's about 56.32 grams. Okay. So, I can clearly see that O2 produces less H2O. Therefore, I'm going to run out of O2 after 56 grams have formed. I will have excess H2. H2 would last until 89 grams of water had formed. But O2 is going to run out after just over 50 grams of water is formed. So O2 is my limiting reactant. And we abbreviate limiting reactant very simply LR. Okay, so O2 is my LR, or my limiting reactant. All right. Let me erase this work because I need a little bit more room. It also asks for the percent yield to know exactly how accurate or how well the laboratory conditions did. Well, I know that my actual percent yield, let me write the equation, is actual over theoretical times 100. I know my actual is 50 grams of water. So 50 grams of water formed. However, oh shoot, and I erased it. I believe the O2 was 56.32 grams. So my actual is 50. I theoretically should have gotten 56.32 grams. All right, I divide those two, multiply it by 100. Ooh, okay, so 6 is just over 1. That means it's going to be less than 9%. It's probably going to be, I don't know, 89%. So my percent yield was 89%. All right, hopefully this helped out. You figured out how to do limiting reactants. You were able to figure out which one of the reactants would run out first, as well as figuring out exactly how much formed, or my percent yield, how much of the theoretical form and the percentage form of that. All right, I hope this helped clear some things up. Thank you.